We're gonna, like I said, we're gonna kind of trek back a little bit onto the slides we've already kind of shown, just to give an idea of exactly what you're gonna be doing with the system. So if you finally have your R set up, I gotta change this a little bit because it's hard to see. Just, yeah, there we go. So under the file system, you're gonna see new files. Now, as I said, that R is integrated with a bunch of different programs. The reason why is because they're trying to shift it from what it was originally. It used to be R, and that's it. Now they're trying to make sure that it's integrated, so it's basically sort of works more like Python or other type systems that allow you to branch out into other programs. That's why you're going to see a bunch of different types of things that you can actually use. So RScript is the primary one that we'll be using today. But if you wanted to use Quattro, something called R Markdown, which is what I built the slides as well as some PDFs in. The Shiny is basically something that you see in terms of websites that'll actually show some of the R coding and other things, those dynamic type graphs. You can also, like I said, use C++ and a bunch of different other ones here. It's trying to become more of an all-around. That's why they're actually sort of switching the name to Posit instead of just RStudio, so that basically it's not just known for R. But for right now, we're going to be using the RScript one. Now, once you do that, there is a shortcut, but I just wanted to show you this one. Basically, it becomes a clean slate. And this is where it can be helpful to sort of kind of, like I said, go through some of the things that we were showing on the other slides. Because if you look at my system right now, under my environments, you're going to see a bunch of stuff. All these things that are already stored there, they're in the cache, and basically they can interfere with some of the stuff that I'm doing, especially if I'm really bad at naming things. And I called one called DF for data frame. Then I try to call another one the same thing. It causes issues. So one of the things that we need to do in this breakdown is basically turn this into a, fresh, clean environment. So like I was saying is you would basically want to start out by that. Yeah. Oop. Usually I have it in front of me, so it's a little bit tricky to do it this way. So basically what I did was I just basically ran this by you can either highlight the line, or in my case I was on that particular line, that's why it ran it. But basically from doing that, you can see that now my environment is clean, in the sense that basically I don't have anything there from previous attempts. But it also clears a lot of the other stuff. So when it comes to that, it also basically takes me back to no plots, no packages loaded other than the base. Okay, I have nothing else there right now. Okay, so I've shown you how to we can do the libraries there, but we can also, if we wanted to, I could actually just click on one of these. If the library is already there, or the package is already there, I can basically pick it just by clicking on it here, and you'll see that the system will go through and load it so that now it's available to me. Okay, so that is one way of actually going through. If you don't know the name, or you know a portion of the name, you could basically go over to here and do a search for it. Like I might remember that for quantile regressions, that I only know that it's called quants. And then from that, I can basically do a quick search that allows me to find the particular package that I'm looking for, hopefully within there. Okay, so basically by doing this, you can, as you kind of get used to it, you're going to kind of use this these interface a little bit more. But as you start getting more and more familiar with what you're doing, you're basically going to just know, I know that I need this library. I'm going to type it in, it'll load it, that's fine. I don't have to do the search for it. Okay? And then, like I said, you also have the help, and then viewer, which I don't really use very much. And then you also have, I don't remember what the last one is called. Presentation. Those last two I don't use, as you can tell. Okay, so from this, basically this is where we start. And you always want to start yours off by using some type of script. You don't always remember exactly what you're doing. You can print some of this if you wanted to, but it only has a certain length unless you increase it. So basically this only goes for so long, but if you want to actually run your programs, or to, the successful ones, not the ones that were messed up, in the sense of trying to code something, you always want to create a script for those. Okay? And the other thing is that we need to do is also know the directory we're in. So right now, because I refreshed everything, my directory is set back to the basic documents. If that's where you want the things, that's fine. But if you want it to be a little bit more, I have my research in this folder or another folder, you need to basically go about setting these up. So when you do this, you could either set the working directory, or in my case, let's see, that's the same place. No, let me. Okay, so my directory, actually I shouldn't have called that data. I probably should have called it something else. But basically I can set up different areas. Actually, let me change this up a little bit. So I'm setting these paths up ahead of time, so that if I want to, the next step so I've set the directory to home first. I can make sure it did it. Okay. So when I set up my projects, basically I usually have 4 primary folders. I have basically the literature that I'm using as one, the data as the other, outputs, and then script files. So basically I usually have 4 of those set up that allow me to jump in those. So if I want send my results as I'm going about my work, I want it to go to that so that I can find it later. I make sure that I change this directory right before I actually produce that work or I export something. If I'm calling in data, I make sure that I'm actually changing to the data, grab what I need, and then I can basically go back to the home. So that's one way you could do it. I'm, I guess, a little particular on how I've set everything up so that I know I can find things. But if anything else, even if you don't do it that, that method, knowing that here's the primary folder where I'm going and this is where all my stuff is at least helpful. Okay? So again, you can do it where you have multiple types of folders that help you separate out everything that you're doing, or you can just do it as one. But after I've done this, anything that I produce, anything that I send out, anything that I call in, it's always going to look in that folder for me. Okay? And that's a little bit helpful so that basically it's not always looking in different places. And then once I've done that, Well, actually, I didn't have it set up the right way, but you can also change over those set everything up in there to see what's in that folder, but I didn't do it this time. But I can see the directory. Basically, by typing in the directory, I can basically see these are all the files that are contained in that particular folder, even if I forget what they are. Okay. Now, these are all things that you're going to kind of get used to as you're setting all these up, or as you're using this more and more. How you use these shortcuts to basically find what you're looking for instead of actually going in and hitting the folder and then going and finding it, figuring out which directory it's in. This is a little bit quicker sometimes, but it does, again, take some time to get used to it. Okay. So let me see, I'm going to set up. So if I've done it right in the right font format, I should be able to paste some of this stuff in to my R. Oops. Oh, I'm already in there. That's why. Oh, actually, no, sorry. I never actually set up this in that folder, so that's why it's not working. Let me just change this to here. Okay, yeah. So as you can see, for the most part, you should be able to copy and paste some of the chunks that's what I'm referring to, those squares that actually show some of the code. You should be able to copy and paste most of those in. There shouldn't be any issues with the font, but just in case, you might have to type a few of these in. But here, now, I'm ready to go. Okay? So make sure that you've done this if you have not already. You don't want to go tonight to sort of try to find all this stuff that you've been working on. Okay? So once we've done this, we can actually play around with some of that other coding that we were looking at. Okay, so who's already went through and tried to take some of these packages here? You had no trouble whatsoever. Okay, so there are a few tricks to doing this that, again, you'll get used to as you go along. But at the very beginning, when you're starting to do this, these packages are not standard within the base. You need to install them. So in many cases, you need either to do the install, like I showed you on that slide, or you actually need to basically come over to packages and then hit the install. Now these are going to always be base packages for the most part. Okay, that doesn't mean that they're the only thing available to you. There are many different ways of getting additional packages that are not standard on the Crane website. Okay, in this case, it's going to be, this is where you have a little bit more flexibility in what you're doing. There's something called dev tools that allow you to download directly from GitHub and other places. Those are packages that might be on Crane, but sometimes they're not, which then you can basically be ahead a little bit, because a lot of times the problem with using these other programs, you're waiting for them finally to create these packages, where somebody got tired of waiting and actually did it themselves. That's good, because if you're not great at programming, but you know roughly what you're trying to do, those things can help you a little bit. To give you an idea, so one of the ones that you could look at, we'll be using later, is like the quantreg package, right? So we have, the quantreg basically is the base for all things dealing with quantiles. Basically, if it comes with truncation type version, censored, various versions that deal with fixed effects, all these things. It's all sort of contained within this package. But you can see that they've basically created other ones, so the non-parametric versions of these, ones that use what's referred to as lasso, we'll kind of discuss that. Then you also have one for forest. Forest is for machine learning and other things. That's what I'm trying to say. So it's not the pre-package and that's all you get. You can actually add on to this to do a little bit more of what is being sort of, the research is sort of being done now. Okay, so that's one way of doing it. Others are basically set up for, I'll just show you one of the websites. So this is a GitHub repository here. And some of these, what they've done is they've actually created functions that allow you to download these or to, use the functions. They give you a description of them, and they also allow you to create documents of these. So that's why I'm saying it's a little bit more robust in the sense that you can basically go beyond what's in the standard contained base packages. Okay, so for this one, this is it's a lecture on multinomial regressions. Then you also have one that I created for an estimation type for spectile regressions. But these aren't things that you would get out of the base packages. They're things that people have worked on. They want to make them available. And when they do, it basically speeds up a lot of the research that we can do. Okay? So there's newer papers that you read in the last 3 years that basically you're still waiting for the program to come out. Maybe it's already out there. You just need to find it in terms of those repositories. And once you find it, you can then cite the people and work on it. Okay? So it makes it a little bit quicker to be available. So if it's not on the install packages side of it, look and see if they might have actually put it in other places. Or somebody's, taken the effort to, put it out there for you. Okay? So keep that in mind when you're going through these, that basically just because you don't see it here doesn't mean that it's not available somewhere else. Okay? And that's the good thing about it. They basically created these programs that you can still install even though, they're not within the base. You can basically bring them in from outside. Okay? But if you went through any of these, you're going to notice that basically you need to install all these. Once you install them, then basically they're available to you to use. Only once you do the library side of it does the current session that you have actually make it available to you. Like if I haven't loaded this yet, if I haven't loaded this, what referred to as ggplot, it's a visual type program. So I haven't loaded it yet, but if I ask for it, okay, maybe I did already load it. It should have told me that it didn't know what that function is, but apparently it loaded something. But basically it would tell you that it doesn't understand what that function name is. Until you load it, that's the only time it starts understanding it. Okay? Yeah.
So if my thing says there's no package called ggplot, do you think the code is different?
No. So that's where this... So I've already loaded ggplot. I have a lot of packages I've already loaded on my system. If you haven't loaded it before, this is where you have to do the install. So you have to do the here we go. ggplot2 in this case. Once I do this, then I would basically click install. Or you could do the thing I put on the slides for, I'll put it. No, where did I put it? Yeah. So you can either do the click one that I was doing, or you could just basically tell it to install packages. And the thing is, whenever you do this install package like this, you can actually, after that quotation, you could put a comma, put another package. You could actually load all the packages at once. Yeah, so there's, like I said, there's multiple ways of doing it. And as you sort of start using it more, you're going to notice that you're going to stop using the click sort of method of it, and you're going to start just knowing that, if I want to install a package, install packages, parentheses, quotation, and then ask for it. So it's just, if you're not familiar with the packages, you can sometimes search with the install packages, clicking version. Okay. So yeah, to use some of the stuff you're going to do today, you're going to actually have to install these packages. And so we're going to kind of go over that as we try some of these. Okay. Okay. Okay, and then, like I said before, we were going to try some of these. So if basically I ask it to do a little bit of math, then it will do it. I can also set up the logical operators like I did before, and basically it would give me some information on this. But a lot of times, especially if it's some type of, string, then we will have to say, print or anything like that for it to do certain things. Okay? And the only reason I'm showing this is because a lot of times when we're doing some of these tables that we're going to produce and everything, a lot of times we want to see them before we actually push them out to any type of program. So, the print or the some of the things that we'll be showing will sort of help us get a visual of what it looks like. Even though it's still going to be in some sort of version of text here, you get an idea of what it's going to look like if you try to print it out. So we're going to kind of go through these as well. Okay? Okay, so I won't really play around too much with the math thing because it's just basically showing that, yes, R can do math. So I'm going to focus a little bit more on the class stuff in terms of, how they're defined. Creating objects and things. So a lot of times we're basically creating some type of equation or something else. So notice that I haven't defined A and B yet, but I'm going to tell R this is exactly what A and B are. Okay? I'm giving it some type of relationship. Well, I got to define it first. So once I define this, you're seeing that once I created the A, the B, and the reg, everything is going up on this side here, right? So right now, these are all just numerical numbers. Nothing, everything's pretty straightforward. But it also can be, something that's a little bit more complicated. So you notice that it didn't actually save the A equal B. What it did was just tell me what the answer was. False. Yes. Oh, so most of this is just coming from these slides. Yeah, I'm trying to follow some of the information from the slide. So before I was just giving an overview, but I'm trying to show you a little bit of what we do in on the fly a little bit, just to see that you get a little more comfortable with it by practicing. Okay. Okay, so in this case, it's the same stuff that we had before. We can go a little bit more complicated in terms of the matrix and other things. So let me give an example of that. So you saw what the A and B were before, right? So once I actually called A and B something else again, I basically overwritten what I had before. But from this, we can basically create our objects in this case. But note that before we were only on values. The C is actually a matrix now. We've separated it out. So it's going to separate out the difference between vectors, matrices, and data frames away from just plain values, or in this case, strings as I set up for the paths. Okay, so it's going to sort of separate those out. As your data, as that set is getting longer and longer, it's going to start to stretch out. But you should be able to find anything that you've created, whether it's a value, a string, or a data frame, on that right-hand side. And in this case, we can just simply print out what C is with some formatting, or we can just type in C. Either one is going to be doing the same thing for these simple procedures we're doing. A lot of times you're not going to see much difference between these. Okay? But this, like I said, is just mainly to get you comfortable with typing these things out, going about it. And in terms of the random numbers, just going to paste this here. So for right now, if I just did X, spits out a bunch of numbers, no formatting, no nothing. It's going to give me the list as long as it stays within the max output that it allows in this case. But this is something that typically you're not going to put in your papers, right? You want it to be a little bit more structured in some cases. So in that case, there are ways to kind of add structure to it. In this case, asking for the summary of a particular value will basically create something that's a little bit more structured for me. Instead of a bunch of lists of numbers, I can basically start to see, you know, where the mean, max, min, all those things are at. Okay. And then a little bit more formal, as you get a little bit better with this, you're going to start to see that you can actually be a lot more detailed in how you set this up. And basically, I can start doing, you know, a little bit more information. Not only did I get this, but I also got the uniform and exactly what it was, and with the normal, a comparison across, and they're sort of a little bit more aligned. These are some of the things that we're going to try to show a little bit later in creating tables. So just to ask, so whenever you're creating a lot of the stuff that you do for your research, how do you create your tables most of the time? Do you find the result and then type the numbers into Excel? Yeah. Then you find a mistake a few months later on and all that stuff, or, you know, you take the data into Excel and draw a nice little graph, things like that. So the thing that we're going to try to be doing a little bit later on is to stop you from doing that. We want you to sort of create everything in R or another, whatever program you choose. We're talking about visuals. We're talking about switching the data frames to allow you to reshape data. I've seen so many students that basically they have wide data, and what they'll do is they'll copy, paste, copy, paste. 8 hours later on, they're a zombie because basically, you know, they've just been doing it continuously. But that's where these statistical programs can basically help you, because as long as you give it some information, it can basically do it in a couple of seconds versus hours or days of this work. And that's where, when we're saying reproducible research, is also making sure that the things that you do can be matched by somebody else that wants to do it, but they're not going to go and copy and paste. They want to see exactly how you structured it, because the likelihood that you made a mistake in doing that is quite high, especially if you become a zombie and you're just like copying and pasting continuously. So that's a few of the things that we're going to be trying to do with this, including, like I said, creating these tables that allow us to then print them out in some ways. Now, I'm good with some of the programs when it comes to creating tables. Other ones you're going to notice later on that I'm not, because I get lazy. I have certain ways of doing it, and not all, like I said, not all the packages work well together. So we're going to kind of discuss that as well. Okay? And then the last, like I said, if you want to, especially if it's just output that you're trying to display to someone else, you don't need it to be in a fancy table, but you need to have some information on it. So if kind of go about it, see how this is here. I'm just going to do a simple loop over the values. But the important thing is, if you're doing this for a supervisor or for some of your work, and you just want to present a, just a quick, easy, it's not meant for the papers, nothing like that. It's just meant to basically give them some idea. Basically, if I didn't have this little print and paste here, basically it would just give me 55. And then I have to remember what that 55 was. Or I could basically give myself a little reminder about what it is. In this case, it's the sum of the numbers from 1 to 10. It's basically ways of going about it. But if you look at the actual script as well, you're going to see that these little number signs, or what do you call these? I call it number signs, but the tic-tac-toe board. Yeah, is it hashtag? Oh, okay. Yeah, you're right, hashtag. So in the hashtag, I can basically create comments that tell me exactly what I'm doing. It's one of the good things about creating these scripts, because basically you look at this 3 months later on after you've been doing something else and you're going back to something, you're trying to remember what you did. It's not straightforward all the time if you just have a bunch of equations, numbers, and importing of data. This is all meant to be something that helps you remember what you're doing, staying consistent with what you're doing, and if you're working with anybody else, that they can follow what you're doing. That's why it's always good to have these comments. In those slides, I was basically saying commenting is good, okay? Looking at somebody's work that has no comments, no nothing, you're trying to figure out what they were doing. If they did it wrong, it's even harder to figure out what they were doing. So that's why it's always good to have these little things that, you'd be a little more detailed than this, print the results. It'd be more about telling you what, you were doing before that to get to the final version. Yeah.
So, is it important to also report when we are putting a result about the commands we use to get this result?
That's sort of where this comes to. So a lot of people now, when they actually submit for a paper or anything, they have to submit supplemental work or supplemental material. A lot of times your data goes in there and your programs go in there as well. So a lot of times I would actually, if this was actual work, I would actually give the journal this as well as my data, so that somebody could go through and actually produce the exact same table I did. And it makes sure it's a check on you, because when we're doing this work, before it was always a little bit, I did this and this is what I was hoping to do and this is my result. Now I can say this is what I wanted to do. Here's my code and this is what I wanted to do. And somebody can come back and say, okay, this isn't right. Something's wrong. That's why we want the code to be there that you were doing. It's just a little bit helpful, especially if you want to continue in that area, that you're very transparent about what you were doing. I'm not sure if you've read much in terms of some of the recent articles, but there's been whole areas that they've been basically, they were published for many years, and then all of a sudden people have found that they're not exactly right. Something seems wrong with the research, so they're actually recalling the papers. There's other people that have been found to say, massage the data a little bit to get the result that they want. People, you know, these are the things, and that's why actually we have to be more transparent than we ever were before. A few years ago, it was recommended that you do it this way. After the recent type things with in the experimental side, as well as with, you know, a few researchers and, you know, recalls on articles, this has become even more important, basically. That, you know, you can't, it's almost a requirement sometimes that you can't get it published unless you have supplemental materials and showing what you did, especially if it's not straightforward work.
So when you said it's wrong to massage data, so is it also wrong to manipulate data? So let's say you have monthly data and you want to transform it into quarterly data so that the whole data set is consistent for all the variables. Is that wrong?
Well, that's not really massaging. That's actually, you need it in that format to be able to work with it. You can't have one data in one, you know, time frame versus another time frame. That's not what I mean by massage. I mean, you just have to kind of go and read up on it. I don't want to go into all that stuff, but basically, for roughly what was going on is that some people have released their supposed final data, but other researchers have been able to go in and actually figure out that that number wasn't supposed to be what it shows there. It actually, you can see that it was supposed to actually be a negative or a zero or something else. That's what I mean by massaging. Getting it in the right, like I can't do monthly trade data if all the variables I have are really at a yearly basis. So that means everything that I work with needs to be in the same time frame. So that's not massaging, that's getting it in the right format to do your analysis. When I mean massage, I mean actually my result isn't significant. So if I change a few numbers, now it's significant. Cooking sounds weird to me, so I go massage. But the key is that, see, the thing is whenever you get the data in the right format, you actually tell the reader, I put it in this format because I needed it. You're being transparent with the person reading your paper. If you just say, okay, I just took this data, combined it, and that's it. But when you released your data, you could see that it was in different time frames. That wouldn't be as transparent. So that's what I'm trying to say. It's about just being straightforward, and this is exactly how I did what I did. Now, you can say that in the paper, which you probably should in a footnote or something, but actually releasing the code actually says, okay, now, if you don't believe me, check my code. You should be able to run this, and if there's anything that you find weird, let me know, but also that result should produce the exact same thing. That's why releasing the code is actually good on that side. Yeah, so that's why I'm doing it this way. So basically, I'm just trying to show you that I would take this, and if this was my research, I would actually have all this stuff as something that somebody could look at, try out, and it's also for me to look at as well. So it's always good to not just work in this here, where you're just typing in commands. You actually have here that you have a flow to your work that you're doing. Okay? Keeping that in mind, you can release these as well as for, I think I mentioned it sort of in passing, for creating websites and things like that. So in this case, you can actually release code that actually does this work and shows the work as you go along. And I was going to show that to you as well later on. Okay. Let me see where I'm at on the slides. Oh, so the last thing I wanted to do is basically keep track of the class in terms of, the type of data that we're looking at here. So as I said before, sometimes you really need to know the class of particular types of functions or anything else that you're using. So basically, what should come out of this is numeric for this particular. So I basically sum the value and it's equal to 0. Even after I go and do the operation, it's still numeric. I haven't really changed anything. But it would be nice to know, especially in a data set. Here we go. If something that I have is a factor or not. So, sorry, at 11:40, it was shown to me because I forget these things a lot of times. We should have probably introduced ourselves at the very beginning. We're going to kind of do that. Sorry. Because I was just about to ask, is a lot of the stuff I work in is international trade, development, applied work. But a lot of times we need to know whether something is defined as numeric or as a factor. How those are read in our equations are very important. When they're seen as a factor, depending on how many categories you have, it treats it as a binary or multiple binary variables. Versus if it's numeric, it's seen as, just it's read as a number that then basically, for the lack of most, a better word, is seen as continuous, even though it might be discrete. So a lot of times we need to consider this when we're running these some of our empirical models, because basically, if it was read as a factor, in this case, it would have been read as a dummy variable that represents male and female. If it's numeric, and it would say 1 and 0, it would have seen it as sort of a continuous. So in state, a lot of times it kind of knows which ones are which. In R, it knows the class. It doesn't really keep track of, whether you're thinking about continuous or not. Or at least what I've done. They could have made changes to this. So that's why I typically say that you really should know how to go about looking at the class or, the type of variable. And we could also, I'm not sure if this is going to work. Let me see. And then I could also just basically look at all the different values that come in this. So basically it's telling me this is a 2-factor level outcome with these 2 outcomes possible. But underneath it, because of how I created it, it's seen as numeric. But this wouldn't be the numeric that you would put into your models most time, right? For most times with these, we would want it to be 0, 1. Okay? So these are things that we'll have to kind of keep track of as we're going around. Okay? Okay. So basically, you see me practicing with this R script, going about all these. And what you can do at the very end is basically save these. If you're copying and pasting these over, like I am. Okay. So that sort of takes us through just the, this is how you create variables, objects, numerics. Yes?
So with the factor variables, for male and female, you don't assign the numbers, you assign automatically.
So when I first created it, if I remember right, what I did was I generated the factors. The reason why it's read these is because it's assigning a number to them. Because I don't think I actually assigned a number to them in my code. Let me just see. No, I didn't assign a number to them, but because I told it was a factor, basically it's going to try to assign numbers to them. But when you try to put it into the equation, depending on which function you're using, it would be fine. So the LM most likely would allow you to do it. Other packages for other estimation commands might not like it. That's why you would have to actually shift it over to a binary. Yeah, so there's those little things that, sometimes I'm working in one program that's fine with this. They love it. I can just type it in and it treats it as it's supposed to be treated. I go into another package that's doing a different estimation and it hates it. and then I fight with that program for about 20 minutes to get it working right. Okay, that's what I meant. It's a back and forth a little bit, but in the end, it does benefit some of the research because it's, even though it's hard at first, it does add that flexibility at a later time. So that should have pushed us to the data section. So like I said, these are things that, I mean, we can keep talking about it, but basically it's going to be as you go along, you're going to get used to setting these up, getting them in the, you know, going about how you look at the data. And we will practice some of them later on as well. So, but overall, it should be nothing that's too difficult for the most part, hopefully. In terms of the data, that's where it gets a little bit, not stranger, but a little bit more complicated. Because if you've worked with research, you know that everybody has their own format that they like to use. Sometimes they like Excel, sometimes they like CSV, sometimes you have DTA files, sometimes you have just raw files. There's too many to name most time. The problem is not every program likes to be brought into another program. Okay, so in that case, a lot of times we have to be a little bit, well, we have to basically kind of go through the different steps to figure out what type of data it is, and from that we can basically start to use the right package. This is 4 of the possible 15 that I saw when I did a very simple search. I didn't really write it at the very beginning, but, and I sort of did speak about it though, that you might start to get overwhelmed with the number of packages for almost anything that you do. But all those packages can be confusing, but at the same time, they actually allow for you to be able to be very versatile in how you're reading in the data or writing out the data. Okay? So these are some of the primary ones that I use. Okay? Haven is a very good one for just all types of different file structures. You have the standard reader, which basically goes across different types of delimited. You have the Excel, or the read Excel, which basically looks at Excel type Word format, or Microsoft Excel type formats. Then you also have the Johnson lights, which, unless you're really doing machine learning or some other things, you really probably haven't dealt with those yet. But like I said, there are so many to kind of go through that you find some that you actually prefer to use that help you with what you're doing. Other than that, once we have those, we can basically start to manage the reading, writing, and then data manipulation. Now, that does not mean massaging or cooking. When I say this later on, I noticed it later on, or earlier when I said manipulation. When I say this, I'm basically saying trying to get it in the right format. A lot of times that you have it, you need the right time frame, you need the right wide versus long structure, you need to, in some cases, get rid of data that shouldn't be in there. Okay, you'll see that later on when we're actually looking at some of the World Bank data. Okay, so that's what I mean by manipulation. So don't take that as cooking or massaging or anything like that. Okay, it's basically looking at subsets, merging, and whatever else that we think about when we're putting data structure together. So when it comes to that reading and packages, like I said, these are the ones that I use. It doesn't mean that these are the only ones. Okay? To give you an idea, there is another one that I don't list here, but it's only due to speed of bringing the data sets in. It's called Read Stata 13. Basically, it allows me to bring Stata files in quicker if I need them than Haven allows me to do it. So sometimes it's about speed versus formatting and other things. So like I said, you're going to find ones that you like, ones that you hate, and you're just going to start focusing on those. Okay, so just keep these in mind. I'm going to try to stick to most of these being the same ones that I'm going to be using. The only time I'm going to sort of shift to something else is whenever I'm going to use a formatting version that allows me to bring in data in another way instead of actually going and looking for it. Like, how many of you use like WDI data, the World Development Indicators? So do you usually go to the website, download the CSV file, and then import it? Well, that's the thing. So Stata are, and a lot of them now, allow you to basically get direct access to the database. Don't have to go there. You can basically use the WDI package, bring it in directly, or you can even search their database to find the one that you're looking for. So these are all things that allow you to simplify what you're trying to do, because those steps that you're basically going out, finding the CSV file, importing it in, those are all possible places that human error sort of come into. If you're bringing just in the data sets, and most time is, I'm not saying it never happens, but I've never seen one where I got a faulty version of the data. It was in the right format. Okay, so that's one of the things that benefits you, especially if you're using public data like that. Okay, APIs are used for a lot of different reasons other than just data as well. We use them for one version is you can actually use an API to do, I forgot what it's called, it's a code helper that allows you to basically use AI type systems, Copilot type systems to help you in coding in R. It actually keeps track of those things, or, it helps you along with it using AI. But these are all things that basically you can connect to that give you direct link to them. And that's one of the benefits here as well. Okay? So one of the packages we're going to be using nonstop, so it's one of those ones that you definitely need to load, is the Wooldridge package. The reason why is because basically you might know the graduate or undergraduate textbook, but he has a lot of data sets that are already pre-packaged in the sense that they're in the right formats. They allow for nice examples, so we'll be using some of that to sort of go through some of these things that we're going to be showing because it just makes it easier. Because basically these are well-tested data sets. They're not known to have the errors that we would usually focus on. So basically the Wooldridge package focuses on the introductory, but it does have some of the graduate outcome data sets as well. And in this case, once we load it, we could actually load the package directly from Wooldridge. So basically, if we go here, then once I had that loaded, if I type in data and I do a few, in this case, if I know roughly what it starts with, wage in my case, then basically I can start to look and see where the particular data that I'm calling is coming from. Each of these here is a particular package, so basically I know that the first one, waiters, is coming from the mass program or package, but I can look for the ones particular to Wooldridge. Okay? From this, I can basically download wage 1.
Do these come from the textbook examples?
Well, yeah, so some of these do. He has more than what's in the textbook, I think. But if you're actually using the textbook, he'll say, I can't remember exactly how it's written in the textbook, but it'll say wage1.raw I think, because it's usually a raw data file. But you can download them directly as either R or DTA files as well. So if it says wage one, you can basically type in wage one and you'll find it there. So in this case, it just makes it easier for examples, so you're not always having to find new data for basically examples of, say, logit or probit, something like that. So once I do that and run the data, basically this will be stored under wage one in my directories or on my environment. So basically, if I want to see a summary of wage one, basically once I type it in, all the data has been loaded and it allows me to see all the variables that are included in there. I get to see a little bit of information about the distribution. And it just makes it a little bit easier. I could also, like I said, find this on the online very easily. I can go search for it, download it as a DTA, R, or CSV file, and then load it myself if I wanted to. Or I found this easier. Once we have this, though, we need to sort of show some of the other steps in terms of the reading, writing, and I'm basically copying this from my slide just to make it easier and bringing it over here. So I still call in the data one or the wage one, but a lot of times I need to write it in different formats. So basically, if I want to write out a CSV file of this, if I want to write out a stative version of this, and if I want to save it basically as or read it back in, or read in the data file as a DTA file, or even if you know where the data set is stored online, I could basically call it in directly from the web. It's a possibility as well. It's that versatile. Basically, you can have the file, or you can download it from a package within R, or you can download it directly from an internet. All you need to know is the link. Once you do that, then basically we have all the different versions that we have here, but it allows you to basically share your work with people, students, or anybody else that you need to. Not everybody's going to like R. Not everybody's going to like Stata. They have their own preferences. It allows you to give the format that you need to them so that they can go through the work, if they're working with you or if they're practicing with students or anything else, that they can use it. Okay? So from this is the last one that I use. Basically, if it should still be working. It was working yesterday. I should be able to call it in. And then should be roughly in the same formats that I had before, but I didn't use summary this time. I used something called head, which basically just takes the first 6 values or so to show me that everything was brought in and gives me an information on the variable names. Okay? So you could do it this way, but I wouldn't advise it just because the link for the shared folder, if you wanted to, if I put the file in that shared folder, because you have the link to the shared, you could actually call it in through the same version like this. Okay? So in this case, you shouldn't be starved for basically how or the type of data that you're required to use. You're not restricted in that sense. You should be able to use various formats and also save them as various formats. Okay? So what we'll do is we'll pick up back here at 1 to basically start going through some of these. But just before we do go to the introductions, one thing that I'm trying to do here, or the way I'm trying to set up the format of how we're going about the course, is to basically go with you as we're going through the codes, understanding, and stuff like that. So the only way to do that is sort of for me to know whether it's working or not on your side is for you to sort of be practicing it. So in that case, make sure that you're sort of going and trying some of these codes to make sure everything's working out fine. Because you don't want to get trying this tonight and basically it's not working. Okay? Because by the time tomorrow we start on something else. Okay, so sort of a back and forth and practicing back and forth between us. Okay?